All right. Now let's try to find an algebraic way to do this factoring of trinomial. Now, one of the ways to derive that result is going to be to look in reverse. Now, what does that mean? Looking in reverse means let's start with the factored form, something like x minus a times x minus b. Now, what does it look like when it is FOILed out? So remember, FOILing out means you do 4 of these multiplications. X times x is x squared. Then I get minus bx minus ax plus ab, which I can write as x squared minus a plus bx plus ab. Okay. One second. Let me actually write this as the middle part as plus negative a minus b x plus ab. Second one, same thing. The only difference now being instead of x minus b, it's an x plus b. So you get x squared plus bx minus ax minus ab. And then that becomes x squared plus b minus ax plus negative ab. Same here. You get x squared minus bx plus ax minus ab, which becomes x squared plus a minus bx plus minus ab. And the last one is x squared plus bx plus ax plus ab, which becomes x squared plus a plus bx plus a times b. Okay, so what's the pattern here? The pattern here is the first term is always x squared. The last terms are always products of a and b. And the middle term is always the sum, right? So for example, here, the first one, it's a product of negative a and negative b. And this is the sum of negative a and negative b. And that's where negative a and negative b appear. The second one, it's the product of negative a and positive b, and also the sum of negative a and positive b, which appears here. In the third one, it's a and negative b, they're products and sums, and they appear at the same place. And in the last one, it's positive a and b, they're products and they're sums, and they appear at the exact same place there. So, to factor this, what we look for? We look for two numbers whose sum is the middle coefficient and whose product is the constant term. Okay. For example, here, now we're looking for two numbers whose sum is 5 and whose product is 6. Now to find that out, we start with the product. Now how can you get a product of 6 is 1 times 6, 2 times 3, 3 times 2 is the same thing. You don't have to consider it, but you can have also negative 1 times negative 6, negative 2 times negative 3. Now for each of them, find the sum. The sum is 7, 5, negative 7, negative 5. That's the one that you want. Now these numbers 2 and 3, we are going to use that to split the middle term, and we rewrite 5 as 2 plus 3. From here on, it's the method that we learned before, which is using the greatest common factor. And if you've chosen your numbers correctly, these are always going to factor 2 times to give x plus 2 times x plus 3. Let's do some more examples here. Now here I need the product to be negative 6, right? Now to get a product of negative 6, I need 1 and negative 6, 2 and negative 3, negative 2 and 3, or negative 1 and 6. Now which of these give me, what are their sums? Let's see. Negative 5, negative 5, sorry, negative 1, negative 1, positive 1, and positive 5. I'm looking for a sum of negative 1. So my combinations are 2 and negative 3. So I go ahead and I write this as 2x minus 3x minus 6. Then the GCF factoring, x minus 2 gives me x minus 3 and x plus 2. The next one, again I need a product of negative 6. So that's negative 1, negative 6. Sorry, negative 1, positive 6, negative 2, positive 3, positive 2, negative 3, and positive 6, positive 1, negative 6. The sums are 5, 1, negative 1, negative 5. I need the sum to be 1. So that means this is x squared minus 2x plus 3x minus 6. Then we use the GCF factoring, x times x minus 2 plus 3 times x minus 2, which comes out to x minus 2 times x plus 3. And this last one, if you complete this, this is going to be x minus 2, x minus 3. Okay. So this method is called factoring by splitting the middle term. Okay, now there's one more level for these kind of problems when you have something other than x squared on the first term. So we're going to do that in a separate video. This video is primarily for factoring by splitting the middle term for let's call this cases, for case 1 or level 1 cases. We covered the second level in another video. Okay, thank you.